In this video, we will identify and graph the transformation of the following functions. We have a quadratic function, we have two square root functions, this one, and we have a rational function. So let's start by describing the transformations featured in this quadratic function. I think we'll just kind of do that off to the side right here. Okay, so the idea is that this is the parent function, all right, y equals x squared. And so now here we have transformations. There are actually four transformations going on right here. There's this negative sign, all right, that is a reflection over the x-axis. All right, so I'm just going to write that down, reflection over the x-axis. Then we've got the 2 is its own transformation. That is a vertical stretch by a factor of 2. All right, I apologize for my handwriting. I'm trying not to take all year, and when I write a little bit fast, it gets pretty sloppy. Next, we have this plus 3. When you have a transformation going on inside the function, it's actually the opposite of what it looks like. So this plus 3 is actually going to be to the left 3. So I'm just going to put left 3. And then finally, the plus 5 on the end is a fourth transformation of up 5. And I think I'll just leave it purple. Whoa, heavy ink. Okay, so it's left 3 and then up 5. So those are the four transformations from the parent function. Now, what we need to do is graph the original function and after the transformations. First, let's come up with the coordinates for the original parent function, y equals x squared. So let's just use the x values from -2 to +2. If we take -2 and square it, that's going to be +4. If we square -1, that's +1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. We can graph that. So we've got -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. So this is the classic parabola shape that we are very familiar with. Okay, now let's go ahead and do the reflection over the x-axis, vertical stretch by a factor of 2, left 3, up 5. Let's do all of that. But here's how I want to break it down. Let's think of it in terms of what's going to be happening to the y values versus what's going to be happening to the x values. Let's start with the y values. All of the transformations that are going on outside the function, in this case outside the parentheses, will be happening to the y values. So we've got this, the -2 and the plus 5. This is all happening to the y values. So that's why if I want to calculate my new y values, I'm going to do -2y plus 5. So that's what I'm about to do. So -2 times 4 is -8. And then -8 plus 5 is -3. Are you following all of that? -2 times 1 is -2. And then -2 plus 5 is +3. Negative 2 times 0 is 0, plus 5 is 5. Negative 2 times 1, all right, well, we already have that 1 is 3, and 4 gave us negative 3, so there you go. Symmetry, love it. Okay, now it's time to switch gears and talk about what's happening to the x values. So the x values are transformed by what's happening inside the function. There's only one transformation going on inside the function, and that is minus 3. That's why my new x values can be found by taking the original x values. Wait, I almost messed up. Well, no, okay, I guess I'm about to do it right. This plus 3, remember that this is left 3. So I actually have to do x minus 3. All right, I'm not going to do plus 3. I'm going to do minus 3 because it's really left. So negative 2 minus 3 is going to be negative 5. Negative 1 minus 3 is negative 4. 0 minus 3 is negative 3. 1 minus 3 is negative 2. And 2 minus 3 is negative 1. All right, so now that we have our brand new x and y values, I can forget about the old ones and graph these. So negative 5, negative 3 is right here. Negative 4, comma 3 is going to be here. Negative 3, 5 is right here. Negative 2, 3. And negative 1, negative 3. All right, so you can see that we have this upside down parabola shape happening. Okay, right in here. Oh, I missed it at the end. Gosh darn it. I was doing so well. All right, that's about the best I can do with that. Now, let's slide over and do the same thing with a square root function. All right, so let's start with a description of what's happening to the parent function. Once we do, what are the transformations? So the square root of x, and so the first transformation is this negative 5. Normally we would see this stuck on the end of the function equation. So what we're more used to seeing is a minus 5 on the end. And so this is clearly down 5. So the fact that it's stuck in the front doesn't change that. It's still down 5. All right, so we've got down 5. This 3 in the front, that is a vertical stretch by a factor of 3. And then the little negative sign inside the function is going to be a reflection over the y-axis. When you have a negative in the front, like if I put a negative here, that's a reflection over the x-axis. But inside, it's a reflection over the y-axis. Okay, so this is a square root function. Let's start off with our standard values, all right, because we have to graph the original function. So we have x, y. Now, in the back of your mind, we know what this parent function looks like. It's like this type of a deal. All right, I'm going to graph it obviously better than that, but I just graphed this sketch to show you why I'm picking the x values that I'm going to pick. Because for one thing, I'm only going to pick 0 and then positive x values. But then also, because I'm doing the square root here, I think it would be better if I do values that I can take the square root of. So I'm going to do 0 and 1. Okay, I'm going to do 0 and 1. But then the square root of 3 or 2, those are like crazy decimals. So I'm liking 4 and how about 9? These are all x values that I can take the square root of easily. That's why I'm picking them. And now the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So now I can do a better job of that little sketch that I just swooshed out. I have 0, 0, 1, 1, 4, 2, and 9, 3. All right, that's a pretty good graph. Okay, now if I can actually draw it, that would be great. All right, this is much harder to do with a digital pen than, because I'm writing over here, but then it's showing up on the screen. It's weird. Anyway, now it's time for the transformations. Okay, so we're going to do each one of these transformations. Now, I like to start with what's happening to the y value. I mean, it doesn't really matter, but for some reason I like to do that. Everything that's happening outside of the function, all right, the +3 and the -5, these things are happening to the y values. Okay, so that's why, because of the 3, all right, this is multiplying, so I'm going to have 3y. And then because of the -5, I'm going to have -5, right? Because this is a vertical stretch and then down 5. So that's what's happening here. So if I do that to the y values, 3 times 0 is 0, -5 is -5. 3 times 1 is 3, -5 is -2. 3 times 2 is 6, -5 is 1. 3 times 3 is 9, -5 is 4. Okay, so those are the new y values. Now let's talk about the new x values. Well, the new x values are going to be affected, we're going to get them by looking at what's going on inside the function. In this case, what's going on under the square root. All we have is the one transformation, this little negative sign. So that means I'm going to do the opposite of all of these x values. So in other words, I'm going to do the opposite of x. So that'll be 0, -1, -4, and -9. That gives us our new x and y values. So now we can plot these new points. 0, -5 will be right here. -1, -2. Okay, -1, -2. -4, 1. So we've got -4, 1. And we've got -9, 4. Okay, all right. I just remembered something that I need to emphasize to you. So if you just look at these 4 dots out of context, there's no way for you to know whether or not the graph starts here and goes, well, I kind of missed it, but it doesn't matter. You get the idea. Does it start here and go like this? All right, or does it start here and go like this? All right, with the arrow that way. Out of context, there's no way for you to know that. So don't just plot the points and then have to sort of randomly decide. Keep track of which point you did first. So, of course, the first point that we graphed when we did the blue parent function was 0, 0. All right, so the origin is the beginning. All right, it's the dot, not the arrow. And then the first point that we graphed when we did the transformation was 0, -5. That's this point right here. That tells us that we definitely start here, and then we move in this direction. And then, so the arrow is going to be on that side. Okay, by the way, make sure you put an arrow on there. If you just connect the dots and stop, if I see a graph that just goes like from here to here like that, to where I don't know whether you thought the arrow was on this end or on this end, I'm going to mark it wrong. So make sure that you put the arrow so I know which way your graph is headed. Anyway, that's it for part B. Time to skip down to part C. We have a nice rational function. I see two transformations going on here. All right, we've got this and we've got that. So the -6 on the end is going to be a transformation of down 6. So I know it's going to be going down 6. Now this +3 is inside the function. All right, if for a rational function, if you're in the fraction, then you're in the function. Okay, and inside the function, that's left or right, but it's the opposite of the way it looks. So this would be to the left 3. So it's down 6, left 3. Okay, down 6, left 3. Okay, so just keep that in mind. I don't think I'm going to do a table of values this time. These transformations are going to be so simple that there's really no point in that. One thing that you need to keep in mind is that for the parent function, y equals 1 over x, the x-axis is an asymptote and the y-axis is an asymptote. We have basically memorized at this point that one point on the graph is going to be right here, 1, 1. Look, let me just remind you real quick. If this is the y-axis and the x-axis, the general idea of a rational function, all right, the parent function 1 over x, we're going to have a branch in this quadrant and we have another branch in this quadrant. All right, that much you should have memorized. Specifically, 1, 1, this branch is going to go through that point. You know, like it doesn't seem worth making a table of values over, but if you just think about it, if x is 1, then if you plug in 1, that's 1 over 1, that'll give you 1 for the y value as well. Okay, similarly, I know that this point over here is going to be -1, -1. And again, if I do, if I let the x value be -1, then I've got 1 over -1. That's going to be -1. So I get -1, -1. All right, so those are these 2 points right here. So that's really all I need to start drawing these branches, because I've got the asymptotes that I know. So I know from here it's going to approach the asymptote. I'm going to go with a thicker ink here a little bit. All right, this is really tough to do. Okay, it's approaching the x-axis because it's an asymptote. And similarly, on this end, it's going to approach the y-axis. It's the asymptote. And it's going to do the same dealy over here, approaching the x-axis and approaching the y-axis. All right, so that's what the parent function looks like. Now, notice the origin right here, okay? Now, I need to do the following two transformations. I need to move left 3 and down 6. All right, left 3, down 6. We already talked about that. So the center of this graph is going to move left 3 and down 6. So this is going to be the new center of the graph. That's important because that's where my asymptotes are going to meet. So you really should do asymptotes as dotted lines. On Microsoft OneNote, they don't give you the ability to draw dotted lines. And if they do, I don't know what it is. So I'm going to go ahead and draw these solid lines, but just pretend that they're dotted. Because this is an asymptote, my friend. Better zoom out a bit. Okay, 1, 2, 3, boom. Okay, these are asymptotes. Pretend they are dotted lines. Now, remember the points that were at 1, 1 and -1, -1? Those points will now be here and here, all right, in the same position relative to my asymptotes. All right, so you can see I didn't really need to do the whole table transformation thing because this is relatively straightforward. So I'm just going to approach these asymptotes just like I did before. All right, approaching the asymptote and approaching the asymptote. Okay, approaching the asymptote and approaching the asymptote. All right, and there it is. That's how you do that transformation with the rational functions. All right, let's do one more and we will call it a day. Okay, here is the parent function. All right, we already did a square root function before, so I'm going to try to do this one a little bit faster. Okay, here are the transformations that I see. I see these two transformations going on outside of the function, so I think I'll just list those first. What do I have? So this negative sign in the front is a reflection over the x-axis. Okay. Oh, I gotta be careful about this. When you have a b value like this, see how this is a binomial and I've got this number sitting here, but yet it's a binomial. It's like a two-part thing. You have to factor this out. You have to factor the -1/2 outside of parentheses. So you know what? I'm going to come back to that in a second. Let me just finish with the +4 is going to be up 4, of course. So I'm going to have my up 4 going on. But now we have to factor out the -1/2. So I think I'm going to play around with that off to the side so I can really show you what's going on. I've got this -1/2 x plus 2, right? Well, I need to take this -1/2 and put it outside of parentheses. How do I figure out what goes inside the parentheses? Whatever you just took out, you have to divide by that guy. So I need to divide by -1/2. Okay, now of course if I divide by -1/2, these are just going to straight cancel out. So that's going to give me x. But what about this? A positive divided by a negative is a negative. But then now I have to think about what is 2 divided by 1/2 though. Well, you multiply by the reciprocal. So this is the same thing as 2 times 2. So that's actually going to be 4. So 2 divided by negative 1/2 is minus 4. So we really had to do that transformation. We had to do this factoring before we can judge what's going on. Because really, what I have here, you know what, let me not use red. Let me use blue, my friends. So what I really have here going on under the radical is this negative 1/2 times parentheses x minus 4. And this is what I have to judge when I say the rest of these transformations. For example, look at the minus 4. Inside the function, this is going to be a left or right motion, and it's the opposite of what it looks like. So this is actually going to be to the right 4. So it's going to be up 4, and it's going to be right 4. Okay, now the negative 1/2 is really two separate transformations. The negative sign, okay, this guy right here, is a reflection over the y-axis. Ah, my daughter's calling from upstairs. It's 5 minutes later. She wanted me to capture a spider that was in her room and not kill it and set it free outside. So that's what we did. Anyway, because we dealt with a square root function before, I'm hoping you watch that part of the video, because I'm just going to repeat this part again. All right, we know that a square root function, the parent function, looks like this. So that's why I'm picking x values only that go to the right. So like I'm going to pick 0 and I'm going to pick 1. But I'm also going to pick values I can do the square root of, like 4 and 9. All right, which is exactly what we did earlier in this video. So these values, of course, the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So this is the same parent function that we did before. So once again, we'll have 0, 0, 1, 1, 4, 2, and 9, 3. All right, so far, so good. Now the transformations. Let's start with what's going to happen to the y values. So remember, the transformations to the y value are going to be happening because of what's going on outside the function, the negative sign and the plus 4. So that's why my new y values will be negative y plus 4. All right, so we'll be doing the opposite of y plus 4. The opposite of 0 is 0, plus 4 is 4. The opposite of 1 is negative 1, plus 4 is 3. The opposite of 2 is negative 2, plus 4 is positive 2. The opposite of 3 is negative 3, plus 4 is 1. Now it's time to do the transformations to the x values. That's going to happen based on what's going on inside the function. All right, so I've got the negative sign here, and I've got the 1/2, and I've got the minus 4. So remember, though, that these things are both going to be the opposite of what you would normally think. So instead of being 1/2, it's actually going to be, we're going to be multiplying by 2. So that's why I'm going to have negative 2x. And then the minus 4 is actually a translation to the right 4. So I'm going to do a plus 4. So this will give me my new x values. Okay, so if I do that, so negative 2 times x plus 4. Negative 2 times 0 is 0, plus 4 is 4. Negative 2 times 1 is negative 2, plus 4 is 2. Negative 2 times 4 is negative 8, plus 4 is negative 4. And negative 2 times 9 is negative 18, plus 4 is going to be negative 14. So that's actually going to be off the graph. So we'll have to do the best we can. Again, as I graph these new points, so the old points are gone, and we're going to be graphing the red points now, but keep track of which point we start with, because that's going to be the beginning point as opposed to the arrow that goes forever. So our starting point is the point 4, 4. So that's going to be right here. So that came from this endpoint. So this will be the dot, not the arrow. Then we have 2, 3, which is going to be right here. And then negative 4, 2, which is going to be right here. So we can see that the graph is curving in this direction. The final point would have been negative 14, 1. And negative 14 would have been like approximately, somewhere around in this area. It's off the graph though. But that gives us the idea. And we already established that we were going to start at this point. So we know that it's going to be curving in this direction with the arrow happening on this end. Okay, I missed it a little bit. Let me try one more time. Okay, so that is what the transformation should look like.